Let's do this example here. So I have the graph of the function there, and that's just going to provide some context. So everything that we talked about kind of makes a little bit more sense, hopefully. Here we want to find the absolute maximum and absolute minimum of the function f over each interval. So this is a cubic function, as you can tell by the shape of that graph over there. It's not going to have an absolute minimum or absolute maximum everywhere because it increases without bound, right? There is no maximum, and it decreases without bound. There is no minimum. But if I restrict myself to intervals, then there is going to be an absolute extremum, right? There is going to be at least one point that's taller than everything else, or at least greater than or equal to everything else. So recall from your first derivative, you're probably tired of hearing this, but your absolute extrema, or your maximums or minimums, can only occur at critical points. So I need to find out where my first derivative is 0 and where it doesn't exist. Now note, this is a polynomial, so our first derivative will also be a polynomial. It'll be a second degree polynomial. It's going to exist everywhere. So I really just need to look for the zeros. Our first derivative is 3x squared plus 6x minus 9. Our first derivative is going to equal 0. Let's divide everything by 3. And that's a little bit more obvious how that factors, at least to me. X plus 3, x minus 1. So the zeros of our first derivative occur when x is equal to minus 3 and x is equal to 1. We know from studying the shapes of graphs that 1, 2, 3, there's your minus 3. There's your hilltop, right? That's a 0, or rather a horizontal tangent line right there. And then here's x is equal to 1, another 0 of your derivative, right? Another horizontal tangent line. That one over there seems like it gives you a minimum. Oh, I'm trying to be careful. There we go. Okay, but let's make sure to use the theorem that we just gave ourselves. The maximum and minimum, the absolute maximum and minimum, can only occur at these critical values or at the endpoints of my interval. So let's just test those points. Let's see, what is the function value at minus 6? What is the function value at minus 3? What's the function value at 1? And what's the function value at 4? So here I'm going to plug in the function values. This is just evaluating the points in your original function to see which is the maximum and which is the minimum. Okay, so if these are the only possible places my extrema can occur, then my maximum has to be 4 at 69, or rather, my maximum has to be 69 at the value of 4. My minimum of the function is minus 61. It occurs when x is equal to minus 6. So if we go over to our function and we restrict ourselves to that closed interval from minus 6 all the way to 4, yeah, we see the lowest that this function ever is at the left point of that interval at minus 6. Gives us a y value of, what was that? Minus 61. And the maximum of this function occurs at the right point of the interval when x is equal to 4. What y value is that? F of 4 gave us a 69. Cool. Let's move down to the second interval now. So I'm just going to keep the same function. I'm just going to restrict myself now to the interval minus 4 to 2. So I have to test the same critical values. I guess I shouldn't have erased that. F of minus 3 was 20. The function at the other 0 of our first derivative was minus 12. And now let's look at our function at the endpoints of this interval, minus 4 and 2. So if you plug -4 into the original function, you get a y value of 13. 2 into the original function gives you a y value of -5. So if these are the only possible places my extrema can occur, on this interval, my maximum has to be 20, occurring when x is equal to -3. My minimum has to be -12, occurring when x is equal to 1. So if I get rid of this, and now we just change intervals, okay, we've got this. Now I'm restricting myself to -4 and 2. So there's x is equal to -4. Here's x is equal to 2. Now, what's the maximum and minimum of the function on this interval? Apparently, the maximum was 20 at -3. Oh, it's that hilltop. And the minimum was -12 at 1. Oh yeah, it's that valley.